All right, well, thank you so much for joining us today for this webinar. If we could advance to the next slide. I'm Kelly Hill, Executive Editor for RTR Wireless News, and I'm joined today by, excuse me, Lorenzo Casaccia, who is Vice President for Technical Standards of Qualcomm Europe. Lorenzo, you're going to give us a recap of what's going on in terms of 5G standards and the recent RAN Plenary meeting. So why don't you just go ahead and tell us what's happening?
Yes, thank you, Kelly, and happy to be here and welcome everyone to this webinar. I hope it's going to be interesting and informative for you all. So let's get started here. We can go to the next slide. We are talking about 5G here. The way generally we see 5G is a unifying connectivity fabric for future innovations. This means that we see 5G as much more than a technology that is going only into smartphones. And what we're going to talk about today is the latest evolution in the standardization world, more specifically in 3GPP, where now the entire cellular community has been working for the last 6 months towards a landmark meeting that took place last week in San Diego, which really opened the way towards the second phase of 5G. And the second phase of 5G is going to be really the one that expands 5G into a number of new areas. And that is going to be the subject of today's talk. We can go to the next slide. We can start with a little bit of a recap to see where we are in terms of context. So what is or what has been new in terms of 5G with respect to previous generations? As I mentioned already, there was always the vision that 5G would serve a number of diverse services, would go beyond just voice and data. This is, of course, something that already started towards the last few years of LTE evolution. Very importantly, 5G is also about a large-scale expansion in terms of addressable spectrum. We all know that every cellular generation has always expanded the addressable spectrum in some fashion, from GSM to 3G to 4G. Going now from 4G to 5G, we really have a massive expansion in terms of addressable spectrum, going from the sub-6 gigahertz into the millimeter wave range. And then very different, very diverse deployment scenarios that also match the different services. So this is the overall context. Now, if we talk a little bit more about where we are in terms of standardization and what is the actual context in terms of industry development, let's go to the next slide. We have Release 15. Release 15 was also concluded last week, which was in itself another major milestone. Release 15 is the first release of 5G, where the baseline 5G has been defined. It is also the release where we have defined the version of 5G that will power the next phase of mobile broadband. And during Release 15, from the Qualcomm team's side, we have contributed a number of major inventions that really have defined a bit the characteristics of the system. And here there are 5 of those general principles that really are the building blocks of the first generation of 5G and all subsequent ones. Just to mention one, the first one, without dwelling too much on the geekier details, scalable air interface. The concept of scalable air interface, it's really correlated to what I mentioned earlier. There is a large range of spectrum bands that is addressed by 5G. That was one of the fundamental goals of this new technology. This means that you've designed an air interface. The air interface also has to scale for different bands. Different bands have then different physical characteristics in terms of propagation, whether you're talking of 600 megahertz, 700 megahertz, or you're talking about millimeter wave. So there are some specific techniques with which the same concepts scale up or scale down in terms of the air interface. Of course, OFDM is very well suited for those type of things. So this is just to provide the general context. Release 15 has provided the foundation, has provided the key technologies. And then if we go to the next slide, we can put now release 15, release 16, we can put the overall flow of the work on a calendar, and we can really see where we are. So let's spend just a couple of extra minutes on this specific slide. So we see where we are here. We're in the middle of 2018. Now, what has happened is that until last week, the priority of the work was on the completion of release 15. Release 15, as I said, was the first version of 5G. It includes two variants. One is called standalone, one is called no standalone. There is a little bit more in the subsequent slides on that. Those two variants that I will recap in a second will fuel the first phase of commercial launches of 5G, which will take place. You'll see something very early at the end of this year, but really you'll see something happening in 2019, 2020. And that's going to for EMBB, and also that is what will create the economy of scale for the fundamental components of the technology. At the same time, from now on, we are starting 3GPP release 16. Release 16 is going to be the second phase of 5G, and that is when we are going to have the expansion of 5G into new areas. That's when we are going to take the foundations that we have defined in release 15, and we are going to apply them in a number of different areas. This will be true for NR, for LTE. We'll talk about that a little bit later. What is more important to mention is that really release 16 is going to be critical, or is going to be the culmination of a number of years of work where the cellular industry really tries to expand into a number of verticals. And in fact, what is more interesting to see is that where you have a number of verticals that are expressing their desire to move to the cellular platform. This is going to, of course, be very exciting from the point of view of cellular technology, from the perspective of somebody that has been working on cellular for some time, to see this renewed interest, or this increasing interest in cellular technologies from many different industries, from many industries that you wouldn't consider traditionally to belong to the cellular family. And you'll see deployment of those technologies towards 2021, 2022. So the bulk of the talk today will be on that, will be on the expansion of 5G into new areas. I mentioned earlier, standalone, non-standalone. Let me give you a recap on that. Let's go to the next slide, and the next two slides will complete this recap. We'll put things in context. As I mentioned, non-standalone, that's part of 3GPP release 15. This is for mobile broadband. This was the first version of 5G, was completed in last December. This is a specific network configuration where you use the 4G core network, you use the 4G radio access network as an anchor to introduce 5G in a sort of supplemental carrier sort of configuration, to abuse a little bit the terminology. So this is the old concept of carrier aggregation, which is generalized here to aggregate 5G and LTE with an LTE anchor. This, of course, is the enabler for the fastest introduction of 5G, because you can really introduce 5G gradually, leveraging all of the LTE infrastructure. It's important to note this no standalone type of configuration is really a novelty in terms of in 5G. There was no equivalent configuration when we moved from 3G to 4G. So this was already completed. In terms of the core standard, of course, there's a lot of things to iron out at second, third, and fourth level of detail in terms of the technology, but this is what everybody is working towards for earlier commercialization. From that, we can go to the next slide. In release 15, we also have completed standalone. This was officially declared completed last week. You probably by now, if you follow the trade news, you have seen various announcements, pictures, group pictures, and assorted celebration. This is what allows now to introduce the 5G core network, which has some specific attributes in terms of network slicing, management of quality of service, and so on, and allows to have the radio access network, the 5G radio access network, to stand on its own feet, so to say, not to need a LTE anchor. This is also part of release 15. There will be also some earlier commercialization efforts based on standalone. One thing that I get asked often, is worth mentioning from the get-go, these two different versions from the point of view of fundamental technology elements are absolutely identical. So from the point of view of hardware components on their interface, which are really the ones that tend to drive the industry pace, they have no difference. The existence of all these variants has a lot to do with expected deployment scenarios from operators, which in turn depends on the industry band, on frequency bands of interest. I mentioned earlier that in 5G we have a large variability of frequency bands, and also it depends on the core network plans of different operators, of different parties. So that's why we have these variants. Sometimes it can be a bit confusing, but in reality, there is the same foundation beneath all of these variants, standalone and non-standalone. Okay, so this is all for a recap. As I mentioned earlier, what really we did last week was to start a portfolio of new projects to expand 5G into new areas. So let's get into that without further ado. We can go to the next slide. So what I'll do here is to provide a bit of an overview of what we are going to do in the cellular industry in the next couple of years, effectively. So there is a work program that 3GPP has agreed to, and I'll talk in one way or another about everything that is in this slide at different levels of details. So at the center, we still have enhancements to mobile broadband. EMBB stands for mobile broadband. So there is a family of enhancements for mobile broadband that goes without saying. But what is most interesting is family of the projects that go into different areas. So we are going to have a set of projects that bring 5G into the industrial IoT space. This relates to, but is not limited to, the acronym that many have been using or have been mentioning, called the URLLC, so ultra reliability and low latency. We're going to have projects that bring 5G into V2X, because we already had one in LTE, but we'll have more of that, and I'll talk about this. We'll have project bringing 5G into unlicensed spectrum and spectrum sharing. We'll have project that brings 5G into integrated access and backhaul. So this means using 5G not only as an access technology, but also to be a backhaul. So this is also referred to as a self-backhaul. And this is very important because as we move high in bands of interest, the density of the network needs to go up just by the laws of physics. And often the limitation to densify the network is given by very mundane issues such as backhaul. How do you bring a cable to a site? And with these integrated access and backhaul technology solutions, what we try to do is to allow cells to be the backhaul of themselves, to use the same radio technology that they use to serve users, to also be the backhaul of themselves. Then 5G massive IoT, I'll talk about that, how we are going to continue this expansion of 5G into the low power IoT space. This is different from the industrial IoT. And then broadcast, this is another interesting space of expansion for the cellular industry. Positioning, that especially indoor positioning, there's going to be another stream of evolution. And then we filed under others just because we couldn't fit more of those into the slide. But it's worth mentioning under this category, since there won't be a specific slide afterwards, that we are going also to have a project to expand 5G for satellite communications, which really what it means It means that there is a very solid interest from the satellite community to leverage the 5G technology ideas to design a next generation satellite link, so to say. So this is a satellite communication for backhaul, for example, where of course the satellite community is interested to join the 5G family and leverage the wealth of innovation that is going into 5G. It's a very interesting development. Just to spend a second on that, because of course typically you wouldn't think of satellite space as being very related to cellular, but it actually shows the amount of energy, of enthusiasm, and the amount of innovation that goes into cellular, since it has a sort of magnetic force towards other industries that want to join in. And okay, very good. So after that, let's go now a bit deeper into a few of these areas. We can go to the next slide. The first one that I'll talk about is this private 5G network for industrial IoT use cases. So what this is all about? This is about taking 5G and taking the fundamental ideas of 5G and trying to use them to provide communication in factory settings, industrial settings. There's a lot of acronyms that are used for that. But if we imagine a scenario of a factory, we have a set of different requirements for connecting robots or connecting equipments. And what is very interesting today is that if somebody walks into a relatively technologically advanced factory, there's a certain amount of machinery that is either not connected or is connected with wires. And there is general desire to connect equipment, if possible, without wires. And which wireless technology is the most suited to do that? Now, of course, we are developing 5G, so there is a strong interest from the point of view of the industry to move into to use 5G for that space. There are several technology components that are used for that. We can go to the next slide, which really shows a little bit, gives a little bit of color of what happens here. So if we, when we talk about a factory, we talk about a scenario like this. So we have robots that are moving, we have vehicles that are moving around, we're going to have cameras that are sending data back, we have sensors, we have people that use head-mounted displays. All of these things have a large variability in terms of requirements. So what do we have here? If we take all the use cases that we see in the picture and we decompose them in terms of technology, we have for some users very high data rates. For some other users, not so high data rates, but we have very low latency requirements. For some users, maybe we don't have big constraints in terms of battery consumptions. So really, we don't have. We are in a very different space than the massive IoT. Of course, we have instead some other cases where we are in the space of massive IoT. On the other hand, and then at the same time, something else that is overarching the entire picture. We have a network that is sort of self-contained. So we have an entire network that is geographically contained, and where the items that are connected are not going to move out of this geographical area. So really we have a bit of an island. And this also means something else in terms of technology. So we have something that can be called a private network, for example. And how does this private network then relate to the larger networks that are surrounding the public networks? So these are all the sort of things that 3GPP will try to address. All of the things that I described. How do we provide very high reliability? How do we provide very low latency? How do we trade capacity and power consumption for latency and reliability? How do we introduce all of these knobs into the system such that somebody can take 5G and deploy it into this geographically contained area? How can we make sure that somebody is actually able to do that So to deploy 5G into a geographically contained area, maybe they use the same spectrum of the operator, they lease a spectrum from a cellular operator, or maybe they use unlicensed spectrum, or maybe in some countries we know that there will be spectrum that is allocated specifically for industrial players to deploy cellular technology in their own premises. So this is all a very interesting space because at the same time you have these mini networks, and these mini networks may and will have different characteristics from the broader smartphone networks. But still, the logic of all of this is not to design a new system, a completely new system. You need still to have a system that has enough commonality with the smartphone network, such that you can leverage the smartphone supply chain. This is the name of the game, of course. We can go to the next slide. From Qualcomm point of view, we've been working on this for quite some time. If anybody of you has missed it, we had a demonstration of some of these concepts. Of course, by definition, there is no standard yet. So our demonstration was a concept level demonstration. In this particular case, at Mobile World Congress, we had been doing some work with an industrial partner, and specifically, we have demonstrated how it is possible to run this so-called Profinet, which is the profile of industrial Ethernet over 5G NR. This is very significant. Industrial Ethernet is really a bit the fabric of everything that I mentioned earlier. So there is Ethernet that everybody knows when you plug the cable into your computer or the printer or whatnot, or used to. Maybe you used to do that in the office. But of course, Ethernet is a protocol that was running on that physical cable. But in general sense, you can run that protocol also without cable. So the idea here is, can we run the protocol without cable and run the protocol over 5G NR? And that's what we've been studying. That's what we have been prototyping and showing at Mobile World Congress. And this is exactly one of the things that 3GPP will define. So we like to think that our demonstration was also instrumental to convincing the industry that it was a feasible direction, it was a sensible direction. Of course, it's very exciting from a business point of view as well, as there is this large space of factories of the future, Industry 4.0, all those sorts of buzzwords, but behind which there is a real community that have a desire to move into 5G. Okay, and that is one of the areas that we're going to work on in Release 16. Let's go to the next slide. Something else, cellular V2X. So what is cellular V2X? The concept of V2X in itself is not new. We had 2 releases ago in 3GPP, LTE release 14. We had the first version of LTE V2X. What was that all about? That was about basic safety. In NR V2X, which is really what we are going to do in Release 16, we are going to take the concepts of NR and define a variant of NR for car-to-car communication and detection. We can go to the next slide to really more explain how all these things relate with each other. As I mentioned earlier in Release 14, we have had the definition of basic safety, and then with some enhancements in Release 15. So that's a space that has some overlaps with IEEE 802.11p, which is another standard, also called the DSRC, that addresses a similar space. So in the general automotive industry, there is a very well understood meaning for the term basic safety or active safety. These are the so-called safety use cases. That's already been done, as I mentioned. Now, what we are going to do for the next 2 years is to look at how 5G can serve the advanced use cases, autonomous driving use cases, and other such use cases, such as sensor sharing. From a practical point of view, things such as your car is detecting something ahead of itself and then can send that information further behind itself to other cars that are coming. So in those cases, you need very high throughput, you need low latency, of course. You also need a lot of spectrum, or relatively more spectrum, because you need to be able to transmit more data. So that is going to be also something very interesting. Even in this case, similar to the previous case for industrial IoT, you have an entire new segment of the industry which is starting slowly but steadily to get interested in cellular communication. There is an external group, of course, that exists called 5GAA, and there are more members of 3GPP that are coming from the automotive space. It's again, of course, is very interesting from technology point of view, in terms of diversity of scenarios that we work on. Of course, very interesting from a business perspective. We have also in this case, if we go to the next slide, we have been looking at this as well in terms of demonstrations at Mobile World Congress 18. We have the concept level demonstration of those concepts. Even, sorry for the repetition, even in this case, goes without saying what we demonstrated on Mobile World Congress 18. It was the general concept. There is no standard yet, of course. We know what we want to do in terms of technology to be standardized. We look forward to get to work in 3GPP with all the other companies to do it. But we demonstrated the feasibility of the fundamental ideas. And then going to the next slide, we can again shift gear to yet another space. This is unlicensed spectrum. This is, technically speaking, the study on 5G into unlicensed spectrum has been already ongoing for 6 months, more or less. But it also is part of Release 16. This is just has to do with the vagaries of 3GPP. Some projects start earlier, some projects start later. But in the end, everything comes together. We all know cellular into unlicensed spectrum is not new to 5G. We have LTE into unlicensed spectrum. That's also a big reason why we have a gigabit LTE. Gigabit LTE at the end is based on LAA, so LTE into unlicensed spectrum. So what we are going to have very interesting in 5G in this project that is ongoing, we're going to look at the same thing. So license assisted use of 5G NR into unlicensed spectrum. So licensed anchor, which could be LTE or NR, and then NR into unlicensed spectrum into 5 gigahertz, for example. That is a natural evolution step. And then we actually are already looking at how to operate 5G NR into unlicensed in standalone mode. That is, from system level point of view, that is very similar to what Multifier was all about in terms of LTE. But this time we are looking at these scenarios in 3GPP. And then, of course, there is a whole family of coexistence activity in RNR, LTE, Wi-Fi. This whole area has also some interesting potential if we look at the next slide, because when we, and on this one, of course, we had several different publications from Qualcomm point of view, so I'm only going to touch on these concepts. Once you put together the concepts of cellular into unlicensed spectrum together with these technologies that are getting mass adoption in 5G, such as multi-antenna transmission, coordinated multi-antenna transmission, such as COMP, then you can look at how you can share spectrum, especially greenfield spectrum, in a more efficient way. So we have a lot of studies that have been conducted that show how you can use unlicensed spectrum, greenfield unlicensed spectrum, in a more efficient manner once you introduce from scratch some of those foundational cellular concepts. We can go to the next slide here. There is a bit of a recap everything that cellular has ever do into unlicensed spectrum, so that it starts all from a big family of evolution paths. So we have had, as we know, NAA, we had NWA, so NT plus Wi-Fi, we had multifier, we had the CBRS concepts in the US, and LSA concepts in Europe. These are all different variants of sharing, and once you put all of this together with some of the 5G ingredients, you can, and the flexibility that 5G gives, that I alluded to at the beginning of my talk, then you can go into more elaborate spectrum sharing scenarios with different types of sharing. This is something that probably will not see the light of day in release 16, but is something that will build on top of the studies that we are doing in release 16. In general, we see that the future of unlicensed spectrum will see more and more the participation of cellular, and 5G will be a big part of that. We have demonstrated some of those concepts. If we go to the next slide, also on this Mobile World Congress 18, we had a concept level demonstration. Again, there's no standard, so we looked at how the whole thing is feasible, why you can really have increased performance at system level if you use unlicensed spectrum, leveraging some of the basic 5G techniques. So as I mentioned, again, this is another big project for the next release of 5G, for release 16. All right, and then we can move forward. Yet another area. I know this seems we are jumping around, but as I mentioned, that's a bit what we are going to do. We're going to have a big portfolio of projects. Now here we are looking at massive IoT. So this is different from industrial IoT that I mentioned earlier. So the industrial IoT into the factories typically will be more about high reliability, low latency, and it will be much less about power consumption. Typically, of course, there's always exceptions. Massive IoT generally is referred to as something where power consumption is very important, coverage is very important, capacity is also very important, and maybe reliability and latency are less important. We have, in the cellular industry, we have already two solutions defined since release 13, eMTC, also known as a CAT-M or LTM, and narrowband IoT. I'm sure many of you, or probably all of you, have heard of these technologies already by now. There is a robust evolution path for these technologies, which is confirmed or strengthened in a sense now, because what we are going to have is that these technologies will get another pass of improvements, and effectively they are going to be the 5G solution from 3GPP for massive IoT. So effectively what you have is a narrowband IoT will be 5G, and eMTC will be 5G. Some of the important improvements that will take place, for example, are different way to run the uplink connection. So to have a more asynchronous type of uplink without grants means you have data, you can send it up as soon as you have it. It's a very important characteristic for sensor networks, not to have to be scheduled. And another very important one, since at the end we've been talking about 5G for the most part, is that you will be able, you're already able in release 15, but we are going to look at some of the associated performance improvements. You're going to be able to run narrowband IoT and eMTC in band 2NR. What does it mean? It means today you want to deploy narrowband IoT in a carrier, and you have LTE on that carrier. So narrowband IoT is just a 200 kilohertz slice of that carrier in the frequency domain. And tomorrow you want to refarm LTE and you want to put 5G NR instead of LTE. You're going to be able to do that, and you're going to be able to keep narrowband IoT in that same space. So that's of course very interesting. And by the way, this is also the concept of forward compatibility of 5G that, as Qualcomm, we have been talking about for some time. Is that concept at work? So you can see that this would have been impossible in previous generations, but instead 5G NR is built in such a way that it can accommodate other technologies in band. And the best application is the in-band insertion of narrowband IoT into 5G NR. It's a very powerful attribute, we believe, for the future. And then we can go to the next slide. Last area that we want to talk about, LTE evolution towards 5G broadcast. Also in this case, that's another example. We talked about satellites earlier. Here we talk about broadcasting. That's also another interesting space. There's been interest from the broadcasting industry to look at how to leverage the cellular technologies and cellular supply chain in the most extended sense for the evolution of broadcast. And 3GPP already had a project on this in release 14 based on LTE, on the NTV. And this particular project resulted in a set of specifications for which there are trials in a couple of places. Now it's most prominently in Europe. There is interest now on, in general, on doing broadcasting on the part of broadcasters using cellular communication, and this is what is called 5G broadcast. And what is going to happen in the next release of 3GPP is that we are going to look at how to take the LTE eNTV from release 14 and make it meet the 5G broadcast requirements. So eventually, again, it's not going to matter too much whether it's LTE or whether it's NR, but what is most important is that from cellular technology point of view, we are going to be able to meet the requirements of this segment of the industry, the broadcasting industry. Because also in this case, very interesting, we have seen more and more members of the broadcasting industry to join 3GPP, attend meetings and so on. It's another interesting development that shows the, say, the vibrant status of our industry. In a sense, the attractive power of cellular. And with that, we have one more slide on an area that I mentioned earlier. If we move to the next slide, millimeter wave. We've been talking a lot as Qualcomm on millimeter wave. Two things that are worth mentioning that are going to happen again in release 16. One, I already talked about it earlier, integrated access and backhaul, cells that are the backhaul of themselves, very critical for densification. And then there is going to be also a study on a very initial study on how to expand 5G into more frequency band, going all the way, going above 50 gigahertz. So there's a lot of spectrum out there. There's a lot of spectrum above 50 gigahertz. There are, of course, very different physical characteristics. There's also an array of regulatory requirements. So we are going to start to look at that in 3GPP. It shows the intention of 5G to be more than the usual frequency bands that were occupied by 4G, 3G, or 2G, but to really go broader in use cases and broader in frequency bands. All right, we can go then to the next slide. We just to recap, touch a couple of other things. Of course, from Qualcomm's perspective, we have been at front and center on all of the initiatives I've been talking about here, because we are very proud to be a part of this industry where there are a lot of brilliant minds and great companies at work. We give a very fundamental contribution to the community, though. We want to also to spend, since we are here, want to spend a couple of minutes going to the next slide on touching on a topic that has to do with 3GPP, with technology leadership. There's been a lot of talks on what it means to be technology leaders. What does it mean to lead in 5G? The way we see is that in general, of course, I've been talking a lot about standardization. Standardization is very central, is very critical to this industry. This is a very fundamental and maybe unique characteristic of this specific sector of high tech, or of all industries in general, that you have technology to go through standardization. This is because of the requirement for interoperation and because of the very high capital costs that are required to introduce new technologies, both on the silicon side and the network infrastructure side. That would be a broader discussion, but really the fact that the industry is very capital intensive drives the need for standardization, which then means technology always starts, of course, from inventions, goes through proof of concepts. I mentioned earlier how we like to try to have proof of concepts for the things that we study. Some of those we showed at Mobile World Congress this year. And then we have a very strong commitment from Qualcomm's point of view into standardization, because that's where then the technology comes into fruition and really becomes part of the ecosystem. And once it gets out into strong standardization, a lot of work still is needed to make it happen in the real world. And that is what we do with trials and with commercialization. So there's a whole family of activities here. We go into the next slide. I already mentioned earlier, from a 5G point of view, we believe we have contributed many of the fundamental inventions that drive the 5G standard in the first version, and they're leveraged in the subsequent versions that I've talked about. So leadership is a lot about looking at the entire end-to-end aspects and the entire food chain. It starts really from the invention, getting the idea proven in an initial phase, moving the ecosystem towards that idea in standards, where which is really what matters, the ability of moving the ecosystem in one direction versus another, and then getting those ideas into the hands of people or users or industries. And then this brings to the next slide, which is about contribution counting, a topic that for those that have followed 3GPP for a long time is somewhat popular. There's been a lot of talks about contribution counting, and is the leader the one that submits most contributions? If any of you has been following some of my earlier blogs, you know that I've published some blogs to explain why that is not the case. At the end, leadership is about quality. Leadership is not a quantity game. It's not about how many papers you submit into a meeting, but it's about what you actually do and what you actually get done. In a certain sense, since innovation in technology is very much a creative act, it's not that different than gauging leadership in terms of who is the most important author or who is the most important artist. It's never about the amount of material that is produced, but it's the quality and the impact of the material that is produced. So, of course, this is a bit of a digression, but it's very important to always keep that in mind. What is really leadership in technology, in 5G, standardization, and so on. And then going to the next slide, how does this all fit into the general picture? From Qualcomm's point of view, as I mentioned, we've been working on prototype for a while. Standards is, and 3GPP specifically, is a unique part of the entire ecosystem that brings us from prototype to the testing and then finally to commercialization with our products, modem and RF front ends. All right, and then we can go to the next slide, and I think we can conclude it here on the 44-minute mark. Of course, thank you very much to everybody that listened so far.
All right. Excellent. Well, Lorenzo, thank you so much. That is a lot to digest, and we have a large amount of questions coming in from our audience. We are going to try and get to as many of those as we can in the next few minutes, folks. So, Lorenzo, let's go ahead and take a question that asks, I thought that any NR IoT, i.e. not NB IoT, would only start in release 17. What does NR IoT stand for? I think this refers to one of your slides fairly early on.
Yeah, this is a bit about of it's a bit of confusion in nomenclature. Unfortunately, this is a classic case in the technology world that people use so many acronyms, everybody gets very confused. So we can do a step back and really think of what we're doing. So there are two different segments. One is the low power IoT, and one is the industrial IoT. So low power IoT is about coverage, is about power consumption, and is not about reliability. So the 5G solution for low power IoT will be to evolve narrowband IoT and eMTC. Now let's move to the other space, industrial IoT. Industrial IoT is a different beast. Industrial IoT is not so much about coverage, because maybe you deploy in a factory. Is not so much about power, because maybe your gear runs on, you have no problem in charging your gear, but is a lot about reliability and is a lot about latency. So industrial IoT is in a different space, and industrial IoT will be based on NR. So there will be specific evolution of NR to address industrial IoT. And this is what I was referring, and others will be referring when they say NR IoT. So they really mean NR for industrial IoT. So these will be two different spaces, low power IoT and industrial IoT. Low power IoT remains with narrowband IoT and eMTC, and industrial IoT will be defined starting from NR.
Okay, great. So we have another question from our audience. Do you have any details about new UE categories defined in Release 16?
Oh, that's a very specific question. Thank you for the question. It's a very interesting area. Now, yeah, UE categories. There is something in a certain sense radically new with 5G compared to previous generations, which is there are not going to be categories. There are not going to be UE categories any longer. So if you have a little bit of history of this technology, the reason why categories existed was so that the UE would signal to the network what it is capable of. So you would tell the network, I am capable of doing 300 megabits per second. That's what the categories were all about. And then people have also used the categories for marketing purposes, and this applies to Qualcomm as well. We have also used categories for marketing purposes. But with 5G, without going too much, without boring everyone too much with the details, the structure of the signaling is such that there is no longer need for the UE to tell the network that I am able to do 2 gigabits per second, because the network is going to be able to figure it out through other means. So there is no longer going to be a category that says I can do 2 gigabits per second or I can do 4 gigabits per second. It's just not going to exist any longer. The network will figure out what the UE is capable of in some other ways. And from a marketing point of view, people will do what they want. People will figure out ways to do marketing in whichever way they want, which of course is the right thing to do. 3GPP will not define most likely any tool for people to use for marketing in terms of categories.
Okay, excellent. So another question here, and this relates to the use of unlicensed spectrum. How will you protect current non-cellular uses with LAA with 5G NR in unlicensed spectrum? Will it be convention-based?
No, there will be very similar mechanisms. So if we consider, for example, 5 gigahertz, right? So the same bands where we already have LAA deployed, you can imagine that we are going to have the very similar listen before talk mechanism. In a certain sense, with 5G NR, it's going to be easier because we have done really a massive amount of work with LAA. Because with LAA, we have defined a listen before talk technology into cellular that allows LAA to coexist with Wi-Fi. Now with 5G, there's going to be a lot of reuse of those concepts introduced with LAA that will be, in a certain sense, added to the 5G waveform.
Okay, so we've had a couple of questions about non-standalone option 4 and option 7. One of our participants asked, I heard NSA option 4 and 7 are delayed. Do you know when they will be finalized? What's the status there?
Yeah, so we didn't have it in the slide, but there's going to be, just not to add too much complication to the update. There's going to be a so-called late drop of release 15, which will be completed in December, and it will be including options 4 and 7. Now, in case everybody or others are curious, options 4 and 7 refer to running non-standalone with the 5G core network. So they are yet again other network configurations where you introduce the 5G network, the 5G core network, 5G radio access, and LTE in different permutations. In one of the cases, the anchor is LTE. In another case, the anchor is 5G NR. As I said, they will be introduced in December. So technically, they will still be part of release 15, but they will be a late addition of release 15.
Okay. Great. Just from the Qualcomm perspective, so now that we have both standalone and non-standalone 5G NR, do you have any thoughts on what we'll ultimately see in terms of a breakdown of deployments? In terms of, will carriers generally look to go to standalone now that it's available, or do you think we'll see significant deployments of non-standalone?
I think we'll be seeing significant deployments of both. At the end, as I mentioned earlier, is nothing really religious, if you will. A lot of this has to do with frequency bands. So and the availability of the core network. So just to make an example, let's take the US, where you have at least a couple of the major operators will have spectrum in the millimeter wave range. And also in the US is unique in that, at least at this point in time, 3.5 gigahertz is not available for 5G NR. And so certain operators, they have a lot of spectrum in millimeter wave, but millimeter wave, of course, will have a shorter range. It will take some time to densify the network with millimeter wave. It's natural to start from non-standalone because they can have LTE as an anchor, and they can leverage LTE, and they can start to densify the network with millimeter wave. Now you take some other parts of the world where they are going to be able to use the 3.5 gigahertz, for example. Maybe they're going to look at starting from standalone directly because they want also to start from the 5G core network directly.
Okay. So another question from our audience. Will today's TV broadcasters acquire new spectrum licenses and adopt 5G broadcast, or will existing operators put today's TV broadcasters out of business?
No, well, that's a very good question. Of course, I cannot predict the future in that sense. Frankly, I just express my opinion. I really don't think the current operators will put the broadcasters out of business. At the end, if you just look at the state of the industry in general, broadcast is all about content. Really, the technology is a transport, and what matters is the content. So people go towards the content that they want to see, and so it is a lot about the content rights. And of course, we can find cases, and in the US there are some very interesting acquisition attempts or acquisitions that are going on in that space, which in fact prove my point. You have to follow the content. But this is a generic comment. From technology point of view, the 5G broadcast can very simply go in the existing broadcasting spectrum. So if you take Europe, for example, or you take China, you have broadcasting spectrum. In that spectrum right now, there are broadcasting technologies that are being deployed. What 5G broadcast is going to do is going to offer a complement or an alternative, depending on how you want to see it, to the existing broadcasting technologies for broadcasting spectrum. So really 5G broadcast as defined by 3GPP should be seen as a broadcasting technology. Is cellular based, of course, but really it is a broadcasting technology. Is to be deployed by a broadcaster towards devices that are on a broadcasting network. Potentially, TVs that you have on buses or TVs that you have at home, in addition to, of course, smartphones and such. So per se, there is no need for new spectrum because you already have broadcasting spectrum.
That's really interesting. I sort of wonder, you mentioned the satellite sort of being folded into 5G and the satellite industry sort of drawing closer to cellular. I wonder if we'll see something similar on the broadcast side, where it isn't necessarily them becoming cellular operators, it's them adopting cellular technology to do what they already do.
Exactly, there's a very, very good analogy. It's also in that case, it's not about satellite operators getting 5G spectrum per se. So there are satellite bands, and they can continue to have their satellite system on the satellite bands, but instead of defining their own satellite system in some other standard group, they use the satellite system, or they will use a satellite system that is based on technology defined by 3GPP. And of course, that leverages the 3GPP supply chain.
Okay. So we had a couple of questions on cellular V2X, and one of them was, in the future, do you see technologies like DSRC and cellular V2X working simultaneously, or do you think DSRC will be replaced by cellular V2X?
So that's a very good question, and I wish I was able to predict the future in that sense. It's clear. The answer is twofold. So I think the question really more applies to LTE V2X, so the release 14 version, so the version of V2X that already has been completed. And I think it's fair to say that there is some level of competition right now in terms of technology between DSRC and LTE V2X. And what is going to happen in terms of one prevailing or them coexisting really is anybody's guess. I cannot easily predict. I think if you look around, you have three regions in the world. You have the US, you have China, and you have Europe. You probably have a different status in those three different regions at this point in time. But beyond that, who is going to prevail? I don't know. For sure, in China, it seems it's going to be LTE V2X for sure. For the other two regions, we have to see. But having said that, NR V2X, so the one that I talked about in this webinar, really does something more, because it really offers advanced use cases, more throughput, or at least that is the aim, to give more throughput, larger bandwidth. And in that sense, that is something for which at the moment there is no other alternative. So it's an advancement in technology that doesn't really compete to DSRC, because that's something that current versions of DSRC cannot do.
Okay. There was actually a question specifically about NR V2X being backwards compatible with release 14.15 V2X, and if so, how? Can you talk about compatibility there on the V2X side of it?
Yeah, of course. So we mentioned that we had mentioned backward compatibility. Of course, these are D2D systems, right? These V2X systems are device to device effectively, because of cars talking to each other. So the concept of backward compatibility is different, right? It's not the same type of backward compatibility that you have when you have UEs talking to base stations. So first we have to be clear on that. It's a different type of concept. It's the same term, but means something different. What it means in this case, it means that there would be common upper layers. So there will be common upper layers, and there will be a sort of common semantics of messages. And then some messages will be routed through LTE V2X, and some messages will be routed through NR V2X. So you have to imagine it sort of as two pipes. So you have a LTE V2X pipe, NR V2X pipe, and a common vocabulary of messages. Some of them are sent one way, some of them are sent the other way. And this also means that in our view, all future vehicles that have an R-V2X will also incorporate LTE-V2X. And that's a compatibility will be achieved by multi-mode. So the 5G V2X, the NR V2X vehicles will also include LTE-V2X, and that's how compatibility will be achieved, because they are multi-mode and because they use the same grammar of the same semantics, the same vocabulary of messages. By the way, it's the same thing that you have at home in your home Wi-Fi. In your home Wi-Fi, you have different versions of Wi-Fi. They are one backward compatible with each other in the same way that I just described for V2X. So they are kind of accumulative. One builds on top of the other.
Okay. Great. So one last question here. As we look at Release 16 and even beyond, what do you see as the most intriguing features that are in the works? And also, what do you see as the most challenging ones?
There are, at the end, I think we can say what is most challenging, and it's difficult to say which one is most challenging here. But I think what is most challenging in general with this phenomenon of expanding cellular is the expansion of the ecosystem. So, this is, there's no hiding that the cellular industry used to be, in a certain sense, very simple, and also cellular standardization used to be relatively simple. So you had companies called operators that were getting spectrum. Either they paid for spectrum, or they were leasing the spectrum, or getting the spectrum for free from the government, and they were running a service for people like you and me. And to run the service, they would get technology from companies like Qualcomm, Ericsson, Huawei, etc., which were building gear for them so that they could deliver a service. So very kind of ecosystem was well formed. Now we've been talking about a lot of things in this webinar. We've been talking about vehicles, which means now you have car companies that are involved. We are talking about industrial IoT, which means you have industrial companies, the General Electric or Siemens of the world that are involved. We've been talking about satellite companies, broadcasters. Some of these companies are of course, very big companies. They see themselves as major players in an economic sense, and in the ability of driving technology. So now you have, so there's more gorillas in the room, and naturally you have some tensions. It's not so much tensions with companies such as Qualcomm, of course. It's more tensions with themselves, because each of them sees as the driving force of the technology in terms of requirements. So that is the most challenging aspect, to have now so many types of different service providers. So a car company will see themselves as service providers for 5G. Of course, an operator sees itself as service provider. Industrial company will see itself as service provider. And that creates some challenges in how to manage the work.
Okay. Great. Well, Lorenzo, thank you much for the insights today. Everyone, thank you so much for joining us today. And this concludes the webinar.
Thank you very much. Of